So when you talk about annuity, we first need to have a review of the major equation when you're talking about interest. So F equals P parentheses 1 plus I to the power n. What this is saying is you have the final value, which equals your initial value times some kind of interest accrued. So 1 is just basically giving you your initial value back, and then you're adding to it a little percentage of that. I is usually a very small percentage. And then you're compounding it, so then you have the number of periods on the exponent. So you keep doing this multiplication of 1 plus I over and over again, depending on how many periods you have. So when we talk about annuity, the best example from society is the lottery. So let's say you're one of the, like 2 people in the history of mankind to win the lottery. Sometimes they'll give you a choice. They'll say, okay, well, you can choose to get all the cash now, and it'll be like a certain value, like that's less than what they usually pitch it for. Or you can get an annuity. And an annuity will be essentially like, okay, every year we'll give you like a small amount, but we'll give you this set amount every year for a really, really long time. And that usually, if you sum it up in your head, it's more than what you would get if you got all the cash now. But you can't really just think of it that way, because now we're starting to think about things like interest and how value accrues over time. So you can't just add all your annuities, like $100 a year, for 10 years. It doesn't necessarily mean that it equals $1,000. So what do you look at? Well, we got to look at a cash flow here. So if you get all the cash now, this is a cash flow. How you read it is the line on the bottom is just time, and maybe years. It depends on how many times you compound a year. And then on the y-axis, you draw your cash flow. So if you lose money, then you're going to have an arrow downwards, and it's going to be the height of how much money you lose. So let's say you get $1,000,000, all cash now. I'll draw it as a positive arrow up, and then label this $1,000,000. And that just means like, okay, here's my bank, here's the money I own, and now I just got $1,000,000 of positive flow. But see, you got all the cash now, so nothing else happened. So maybe this was, t equals 0. This is the 0th year. You keep going ahead, but you're not getting more money anymore. This is the only cash influx you had for the rest of time. So that's what cash now means in terms of a diagram. Now you look at annuity, you're going to get a smaller value than this. Now this is not to scale, but let's say you get $100, and you get that time equals 0. Well, the next year, depending on the rules they set you, they'll give you another $100, and then second year you'll get another $100, and then another 100. It goes on, and then they'll usually have a set time for this, but it could be infinite theoretically. Yeah, that's right. I just said it could be infinite. You could get $100 forever, essentially until you die. Now, the average person might think, okay, well, obviously that's a steal because if I live forever, I'm going to get infinite amount of money. But then now that's when we start thinking about economics and the idea of interest accrued. You're actually getting a finite amount of money, even though it looks like you're getting $100 forever. So how do we find the value of that? Well, let's return to that equation we saw at the very beginning. The final amount equals the principal times the interest. If we rearrange this for P equals the final amount over that interest term. Now what does this look like? This is your final amount you get, and then you're kind of now looking back into the past of how much is it worth n years ago. So if I get F at this point of the cash flow, like at this point we're going to call this $100. F equals $100. But then 10 years ago it wasn't equal $100. The value was something less, and then with this interest it accrued to $100. So then you can write that F equals some number like $100, but P over here is going to equal $100 over 1 plus I to the n, where this is 0 and this is n. So you see that P is a smaller value than F. Now if we start to try to understand how much the present value of an annuity is, what that means is if I draw my cash flow again, and I'm saying, okay, well, I'm going to give you $100 every year forever until you die. and this is 1, 2, 3, 4, 5. Well, you shouldn't think of this as 100 times. Here it's 6 times. You shouldn't think of 600 bucks. You should ask yourself, at this moment, now, what is my present value? PV. Obviously, this first cash influx equals 100 bucks because it's at that moment it's 100 bucks. You can't deny that. But this one, 100 bucks in 1 year is worth a little less than 100 bucks at the moment. And then again, the 100 bucks in 2 years is worth even less than that if you're looking at the moment. You care about present values because you can either get the cash now or you can get it spread out, but you care about that money buying power right at that moment. So how do you write this? Each of these can just be written with this formula here. It's 100 bucks over 1 plus I to the n. And n differs. So in this case it's 3. For this term it would be 5. And you're seeing that the bottom is the one that's getting larger and larger. 1 plus I to some value is going to get to be a bigger and bigger number as you go infinitely in time. So that total value is going to get smaller. So this should start making you wonder, is there a point when your annuity practically is worth nothing? So how you sum this up is, whereas intuitively you would just add 100 plus 100 plus 100, you should think of it more as I'm adding things that are getting smaller and smaller in value, at least in my head, because I know economics. So the way you sum these up is with geometric series. I'm not going to explain it in this video, but if I do A plus the next one, which is 1 plus I, one time it had interest once. The next one is 1 plus I squared, on and on and on. Using the notation of geometric series, you can write this as the summation of n from 0 to infinity of a 1 plus I to the n. So in the first term, n equals 0, so you have a over 1, which is this term right here. And then the next time you turn n equal 1, and then it becomes this term right here, and on and on. So this is describing, in one simple notation, the infinite number of summations you have. Now, I'm not going to go into how you solve this, but in fact, if you do solve this for an infinite series, you get a over I. What does that mean? If your interest is, say, 6%, then you're given the option of getting 100 bucks from now till forever. The present value of that is 100 bucks over 0.06. So it's counterintuitive because you have this idea of you're getting money forever, but in fact, because those individual cash flows are decreasing less and less in value at the present time, you're actually going to get a finite amount from that annuity.